So before we jump into the graphing in this video, let's just summarize everything we've learned so far. So this A value out here affects whether your parabola opens up or down. If the A value is positive, you can think of your parabola as a smile, right? It's happy, it's positive, and the parabola is opening up. The vertex is a minimum because it's going to be at the bottom of your graph. So if you have y is equal to x squared, it looks like this. If the A is negative, so this is y is equal to positive x squared, if we'll have y is equal to negative x squared, what that's going to do is make your parabola open down. That's going to mean that your vertex is going to be a maximum instead of a minimum. And this is going to matter when we start doing what's called max or min problems. They're going to ask you, for example, what is the maximum area that a rectangle could have? And then we also know that if the A value is greater than 1, so if we have something like y equals 2x squared, this 2, you're going to take all those x values, square them, and then multiply them by 2. What that's going to do is make your graph narrower. Okay, it's a vertical stretch. If the A value is between 0 and 1, so if we have something like y is equal to 1/2 x squared, that means you're going to take that x value, square it, but then you're going to times it by half. So all those y values are going to be half what they were before, which is going to make your graph wider. The vertex, as we saw in the last video, is always that h value, so that shift left and right, and then your k value, that shift up and down. And the equation for the axis of symmetry is always x equals h. It's the h value of the vertex. So now what we can do is I can throw every transformation at you in a question. Generally there's like 2 transformations, but sometimes there's 3. Okay, so we're going to try a bunch of them. So leading you through this, we've got y is equal to 2x squared minus 3. First thing we're going to do is look at the A. We always look at our transformations in order from left to right. So direction of opening, so this is going to open up. Because it's a 2, which is greater than 1, it's going to be narrower. My vertex, now there is no horizontal shift, so the x value of the vertex will be 0. And then you've got this k value of minus 3, so it's going to be at negative 3. Axis of symmetry is always the x value of the vertex. Your domain is always XER, or negative infinity to infinity. And then your range, if you want to look at it now, it's always to do with that negative 3. Right? It's always the y value of the vertex. And then if your graph is opening up, it's y is greater than or equal to negative 3. And if your graph were opening down, it would be y is less than or equal to negative 3. Now, as for graphing, there's the quick and easy way to graph, and then there's the proper way to graph. Technically, when you're graphing using transformations, you should always do your stretches, and then you're going to move it left, right, up, and down. So if I was to do that, I would graph this in 3 stages. So maybe don't write this down, but I'm going to show you the proper way to graph it, and then I'm going to show you how we are going to graph it, which is a bit of a shorter thing. So what you do is you graph y is equal to x squared first. So you go over 1 up 1, over 2 up 4, over 3 up 9, and then you do that same on both sides. This is my y equals x squared graph. So if I was to do this in order, what I would now do is multiply by 2. So you see you've got your x squared. Now you're going to multiply that value by 2. So you're going to take all these points and you're going to stretch them. So 1 multiplied by 2 is 2. 4 multiplied by 2 is 8. And then I can't fit that one on. So 1 multiplied by 2 is 2. 4 multiplied by 2 is 8. And I get this narrower graph. Okay, that's step number 2. So this is y is equal to 2x squared, whereas the blue graph was y is equal to x squared. Then what you're going to do is take that whole graph, move it left or right if you have to, which there's nothing in here, and then do your up and down. So I'm going to take this graph and I'm going to move it down 3. So this red graph, I'm going to move every point. Actually, I'm going to choose a different color. I'm going to pick every point and move it down 3. So I'm going to go down 1, 2, 3. Take the red point, 1, 2, 3. Take this red point, 1, 2, 3. And then I'm going to mirror that on the other side. Go there, go there. That was the only one I could fit. So I'm going to go like this and climb. Now, that is a great way to graph, right? And it's showing that I'm taking all those points, and you can actually see that you're taking that y value of 1, multiplying it by 2 to get 2. You can see that you're taking that y value of 4, you're multiplying it by 2 to get 8. And then you can see that you're moving all those points down 3. But this takes a lot of work. So instead, what I would do if I was graphing these, and maybe I shouldn't have just deleted these, but I'm going to show you that it ends up the same, is that instead of having to go through and do my transformations in order from left and right, I'm going to start at my vertex. I said that my vertex is 0, -3. So I'm going to start at 0, -3. And then I know that it's opening up, and it's narrower because the y values are getting multiplied by 2. So if I know my basic shape of a parabola, instead of having to actually change points, what I can do is start at the vertex, and instead of going over 1 and up 1, I can go over 1 and up 2. Instead of going over 2 and up 4, I can go up 5, 6, 7, 8. If I can normally go over 3 and up 9, I'd have to go up 18, which isn't going to fit. So I can mirror on the other side. So instead of having to do these transformations in order, which is if you go on to Math 60, you actually have to do, because we're not going to be using these parabolas, you just are going to be graphing other shapes. You have to go step by step. But because these are all parabolas, and parabolas have a very predictable shape to them, you can start with your vertex and then do your stretching or your compressing, so making it narrower or making it wider. Let's do another one. So what about y is equal to -x plus 3 all squared? First things first, what's this going to open? Well, here's your a value. You have an a value of -1. Because it's negative, you're going to open down. Because it's a 1, you're not stretching by 2, or you're not compressing it by half. So it's actually not narrower or wider. It's going to be a regular shape. Your vertex, your x value of the vertex is this h value in here, which is -3. And then there is no k value on the end, so it's +0. Axis of symmetry is always the x value of the vertex. Now, if you wanted to, you could figure out domain and range right now. Domain is always xer, or -infinity to infinity. The range is always the y value of the vertex. Now, if it opens up, it would be greater than or equal to. But since this is down, it's going to be less than or equal to 0. Now let's sketch it. So let's start with our vertex at -3, 0. Now I know this is a parabola with a normal shape opening down. So I'm going to go over 1, down 1, over 1, down 1, over 2, down 4, over 2, down 4, over 3, down 9, over 3, down 9. And I'm just going to connect my dots. So again, you could have started with your y equals x squared graph. You could have then reflected it over the x-axis and made it open down. And then you could have taken that whole graph and moved it left 3. Or, because it's a predictable shape, you can just start at your vertex and then know what the shape will be. Okay. If you feel like a challenge, you can do this one on your own. Otherwise, just hang on with the video and keep watching. So here we go. Y equals 3 times x minus 6 all squared minus 8. First things, direction of opening. So this is my a value of 3. Since it's positive, it's going to open up. Is it narrower or wider? Well, it's times by 3, so it's going to get a lot narrower. My vertex. The x value of the vertex is your h value, so it's going to be 6. The y value of the vertex is this minus 8. Axis of symmetry is always the x value of the vertex. Domain is always xer, or -infinity to infinity. And then your range is always related to that y value of your vertex. Because it's opening up, it's going to be greater than or equal to -8, or square bracket, -8 to infinity. So when you're sketching this, first thing you do, plot your vertex, 6, -8. Then it's opening up, and it's going to be narrower by a factor of narrower or stretched by a factor of 3. So normally your parabola would go over 1 and up 1. Instead, we're going to go over 1 and up 1, 2, 3. Normally we go over 2 and up 4, and instead we're going to go up 12. So I'm at -8. So that's 8, 9, 10, 11, 12. And then I'm going to mirror that on the other side. And this is my parabola. Oh, that was horrible. I'm going to try that again. This is my parabola y equals 3 times x minus 6 all squared minus 8. So it is narrower, opening up, moved right. So this is narrower, opening up, moved right 6, and down 8. The right and down thing is really, really, really important if you're moving on to Math 60. From a Math 50 standpoint, as long as you know the vertex is 6, -8, it moves right and down. And then from there, you have to determine, are you opening up or down? And then what's happening to your shape? Are you over 1 up 1? Or are you getting stretched by 2? Or are you getting compressed by a half? And then you figure out what it's going to look like from there. Hopefully this makes sense. Go give your graphs a go, move on to the textbook, and hopefully this will be clear sailing.